You know what's absolutely crazy? We spend our whole lives thinking the universe operates on logic, cause and effect. Neat little equations, everything making perfect sense. And then you actually look at what's happening at the quantum level, and the universe just laughs at you. I mean, really laughs. Here's something that'll blow your mind. An electron doesn't just go from point A to point B. Oh no, that would be too reasonable. It goes through every possible path simultaneously. It goes backwards in time. It interferes with itself. And when you try to watch it doing this absolutely bonkers thing, it suddenly behaves and acts like a nice, normal particle, like it knows you're watching. Now, you might think I've lost my marbles. But this isn't philosophy or mysticism. This is what the equations tell us. This is what the experiments show us again and again and again. The universe isn't running on human logic. It's running on something far stranger, far more beautiful, and frankly, far more annoying when you're trying to teach it to undergraduates at 2 in the morning. So let me tell you why everything you think you know about reality is probably wrong. All right, let me start with something simple. You drop a ball, it falls down. Why? Gravity, right? Perfectly logical. Newton figured it out, beautiful equations, everything makes sense. The ball doesn't decide to fly sideways or turn into a chicken, it falls. Predictable, logical, comforting. Except here's the thing, and this is where it gets interesting. When you ask why gravity works the way it does, the answer isn't logical at all. Einstein comes along and tells us space itself is curved. Space, the actual fabric of reality, is bending like a rubber sheet, and that's why things fall. Now, does that match your everyday logic? Does that fit with your common sense? Of course not, but it's true. And that's just the beginning of how weird things get. See, our brains evolved to throw spears at deer and not get eaten by tigers. We needed logic for survival. If there's a rustle in the bushes, there might be a predator. Cause and effect, pattern recognition. This served us very well for a few million years. But here's the cosmic joke. The universe wasn't designed around our intuition. Why would it be? We're just these weird apes who got smart enough to ask questions, and now we're shocked that the answers don't fit inside our monkey brains. Let me give you my favorite example of the universe not giving a damn about logic, quantum superposition. You've probably heard about Schrodinger's cat, poor thing, stuck in a box, simultaneously dead and alive. People think that's just a paradox, a thought experiment. But it's not. That's actually how particles work. An electron exists in multiple states at once until you measure it. Not we don't know which state it's in. It's literally in all states simultaneously. Now, your logic says, that's impossible. Something either is or isn't. A or not. A. Basic logic. And you'd be right about the everyday world. But zoom down to the quantum level, and the universe says, you know what? I think I'll do both. In fact, I'll do everything. And it does. I spent years working on quantum electrodynamics, and let me tell you, the math works perfectly. We can calculate the magnetic moment of an electron to 10 decimal places, and it matches experiments exactly. But what does the math mean? Well, it means particles take every possible path between 2 points, including paths that go backwards in time, loop around Jupiter, and stop for coffee, all of them, simultaneously. And they all interfere with each other to produce what we actually observe. Does that make logical sense? Absolutely not. Does it work? Perfectly. Here's another one that'll cook your noodle. Entanglement. You take 2 particles, get them entangled, and that's a technical term, not just me being poetic and then separate them by any distance. Doesn't matter if it's a mile or a million light years. You measure one particle, and instantly the other particle knows what happened to its partner. Einstein called this spooky action at a distance because it bothered him. It bothered him because it didn't fit with his logical picture of the universe where nothing travels faster than light. But guess what? The universe doesn't care that it bothered Einstein. The experiments show entanglement is real. We use it in quantum computers now. It's not magic, it's not mysticism, it's just the universe being itself and ourselves being confused because we're trying to force it into logical boxes it was never designed to fit into. Now, you might ask, okay, Feynman, if the universe doesn't follow logic, how do we understand anything? And that's actually the brilliant part. We use mathematics. Math isn't the same as logic, not quite. Logic says, if A, then B. But mathematics says, here's an equation that describes what happens, even if it makes no intuitive sense whatsoever. The Schrödinger equation doesn't care about your feelings. It doesn't care that wave-particle duality sounds insane. It just describes what happens, and when you solve it, you get predictions that match reality with stunning precision. That's the beauty of physics. We don't need to understand why the universe works this way. We just need to describe how it works. And the how is mathematical, not logical. Think about waves for a second. Sound waves, water waves, they make sense, right? They're disturbances in a medium. But light waves, what are they waving in? We used to think there was an ether pervading space because that would be logical. But experiments showed there's no ether. Light just waves. It waves in the electromagnetic field, which isn't made of anything, it's just a field. Does that match your everyday experience, your logic? Of course not, but that's reality. And here's what really gets me excited. Every time we peel back another layer of reality, it gets weirder, not more sensible. We thought atoms were like little solar systems, logical, right? Nope. Electrons don't orbit, they exist in probability clouds. We thought particles were fundamental logical building blocks. Nope, they're excitations in quantum fields. We thought space-time was absolute, makes sense. Nope, it's relative and can be stretched, squeezed, and warped. The universe is under no obligation to make sense to you. And honestly, that's the most exciting thing about it. If the universe just followed simple logic, if everything worked the way our intuition suggested, physics would be boring. We'd have figured it all out millennia ago. But instead, we live in this wild, counterintuitive, magnificently strange universe that constantly surprises us, constantly challenges our assumptions, and forces us to be humble about what we think we know. So where were we? Oh yes, the universe is crazy, logic is overrated, and everything you learned in school is technically correct but fundamentally misleading. Let's dig deeper. Now, here's something that really bothered people, and still does, the measurement problem. In quantum mechanics, before you measure something, it exists in this fuzzy superposition of all possibilities. The moment you measure it, boom, it collapses into one definite state. But here's the question that'll keep you up at night. What counts as a measurement? Does it require a conscious observer? Does the particle somehow know it's being watched? People have spent decades arguing about this. Some say consciousness collapses the wave function, which sounds mystical and makes me want to throw chalk at them. Others say the measuring device itself does it. Others say there's no collapse at all, and the universe just splits into multiple branches where every possibility happens. And yes, that's the many worlds interpretation, which is either brilliant or completely bonkers, depending on who you ask and how much coffee they've had. But here's what I think is the real point. We're asking the wrong question. We're trying to force the universe into a logical narrative where things happen in a way that makes sense to us. But quantum mechanics isn't a story about what particles really do when we're not looking. It's a mathematical framework for predicting what we'll observe when we are looking. And it works. The predictions match experiments to absurd levels of precision. Does it satisfy your need for a logical explanation? No. Does it satisfy the universe? The universe doesn't care either way. It just does its thing. Let me tell you about something even stranger, quantum field theory. You think particles are little billiard balls bouncing around? Forget it. What we call particles are actually excitations, little ripples in quantum fields that permeate all of space. The electron field, the photon field, the quark fields, they're everywhere, all the time. When enough energy concentrates in one spot, we see it as a particle, but it's not a thing. It's an event in a field. Now, these fields obey certain rules, and when you work out the mathematics, and believe me, it's some of the most beautiful and complicated math ever devised, you find something shocking. Particle can pop in and out of existence. Virtual particles appear from nothing, exist for a tiny fraction of a second, and disappear. They violate conservation of energy, but they do it so quickly that Heisenberg's uncertainty principle says it's okay. The universe literally borrows energy from nowhere, creates particles, and pays it back before anyone notices. Is that logical? Is that how a sensible universe should operate? Absolutely not. But vacuum fluctuations are real. We've measured them. The Casimir effect, where two metal plates in a vacuum attract each other because virtual particles between them get restricted, that's real physics. We've tested it. And here's where it gets even better. All of chemistry, all of biology, all of the structure and complexity of the universe, it emerges from these fundamentally illogical quantum rules. The reason atoms are stable, the reason molecules bond the way they do, the reason DNA can store information, it all comes down to quantum mechanics. It all comes down to electrons existing in superpositions, tunneling through barriers they shouldn't be able to cross, and interfering with themselves in ways that make no logical sense. You, sitting there reading this, you are a quantum phenomenon. Every thought in your brain involves electrons hopping around in ways that only make sense mathematically, not logically. Your entire existence is proof that the universe doesn't need logic to create something as complex and wonderful as a conscious being. Now let's talk about something that really drives physicists crazy. We can't combine quantum mechanics with general relativity. These are our two most successful theories. Quantum mechanics describes the very small with incredible accuracy. General relativity describes gravity and the very large with incredible accuracy. But when you try to put them together, mathematical disaster. Infinities everywhere. Nothing makes sense. And why? Because at the deepest level, they're based on incompatible assumptions. Quantum mechanics says everything is uncertain and probabilistic. General relativity says space-time is smooth and deterministic. Which one is right? Both of them. In their respective domains, they're both spectacularly correct. But together, the universe seems to be telling us, you haven't understood something fundamental yet. Maybe space-time itself is quantized, made of discrete chunks at the smallest scales. Maybe there are extra dimensions we can't see. Maybe the whole concept of space-time breaks down at the Planck scale. We don't know, and that's not a failure of logic. It's a failure of our current understanding. The universe is being perfectly consistent with itself. We just haven't figured out the deeper pattern yet. Here's what I've learned after decades of doing physics. Nature doesn't care about what's convenient for human understanding. It doesn't package itself in neat philosophical categories. It doesn't respect our intuitions or our desire for clean, logical explanations. It just is magnificently, frustratingly, beautifully itself. And you know what? That's exactly why physics is so exciting. If everything were logical, if everything made sense immediately, what would be the point of investigating? The joy of physics isn't in confirming what we already believe. It's in being surprised, being confused, having nature smack you upside the head and say, guess again, buddy. Every paradox, every counterintuitive result, every moment where the math tells you something that sounds impossible, those are invitations. They're the universe saying, you're thinking about this wrong. Look deeper. There's something more interesting going on here than you realized. So yes, the universe doesn't care about logic. It operates on mathematics, symmetry, and principles we're still discovering. Our job as physicists, as curious humans, isn't to force the universe into logical boxes. It's to follow the evidence wherever it leads, even if it leads somewhere strange, especially if it leads somewhere strange. Because at the end of the day, The universe is under no obligation to make sense to a bunch of evolved primates who only recently figured out fire. The fact that we can understand anything about quantum mechanics or relativity or the structure of reality, that's the real miracle. Not that it's weird, but that we're smart enough to discover just how weird it really is. And honestly, I wouldn't have it any other way. A logical universe would be boring. This universe, this strange, counterintuitive, mathematically beautiful mess, this is a universe worth exploring.